Hello everyone, today in this video we'll be discussing the questions which are like the subjects questions as well as the programs which are more important from the interview perspective for internships. Okay, so like for the theory subjects there are mainly 4 subjects which are important. The first is DSA and second is operating system, third is computer networks, and the fourth one is DBMS. Okay, so these are the 4 subjects, and let's see what are the important topics in each subjects which are mostly asked in the internship interviews. Okay, so if before starting, if you like this video, hit the like button and don't forget to subscribe to my channel. Okay, so first we'll be discussing the theory questions, then we'll be moving on to the programs. Okay, so coming to DSA, the first question is water pointers mention the different memory allocation techniques in C. Okay, so what is a pointer? Pointer is nothing but it is a variable that stores the address of another variable. For example, if n is equal to 10 and if I write int star p is equal to ampersand n, what's actually happening is n will be created in the memory here, its address will be like suppose 100. Okay, and what will p have? P will have the address of this one, which is 100 here. Okay, so p is a nothing but a variable that stores an address of another variable, so p is called a pointer. Okay, so this is the syntax and initialization. And coming to the different memory allocation techniques in C, there are 4 memory allocation techniques: malloc, calloc, realloc, and free. Okay, so first 3 are used for the allocation purpose and the last one is for the deallocation purpose. Okay, so let's discuss what are each. Okay, malloc allocates a single block of requested memory. Okay, for example, if it I write here like 25, instead of this one if I write here 25 bytes of memory will be allocated in the memory. Okay, so that's what the malloc is for. And calloc means what? It allocates n number of blocks for the given size. Okay, for example, if it is 2 here and 5, the allocated memory will be there will be 5 blocks here which will be having the size 2. Okay, so this is what calloc is for and this is the syntax of it. Coming to realloc, realloc just changes the previous pointer's value to the new size. Okay, means if the previous value of the pointer was 10, it was allocating 10 value, means 10 memory blocks. If I change it as 20, it will allocate 20 blocks. Okay, and free is nothing but freeing the memory if it's not in use. Okay, that's for the deallocation purpose. That was the first question. Coming to the second one, what is the difference between structure and union? Okay, so structure is a user defined data type in programming language that stores different data types values together. This is very important, it stores it together. The struct keyword is used to define a structure in a data type in a program. It stores together means what? If I have a structure here, employee, and I can store id, name, department, and email. So it will have 4 columns here. In each of these it will be like id here, name will be stored here, department will be here, email will be here. Whichever I want to access, I can access one by one. Okay, means at the same time I can access. The same thing is in with union as well, but in union what happens is either of this will be stored in the memory. So memory will be allocated this much only at a single time. Either name will be stored here, if I store department this will be overwritten here, else phone number or email. Okay, that's the only difference. The rest of the means the syntax of it is same. Okay, so just the keyword will be union here. And moving on to the third question, give the difference between binary tree and binary search tree. It's pretty simple one. Binary tree means it has at most 2 children. It's called a binary tree. Binary search tree means which all the nodes to the left of the root node. See, this is the left of the root node, this is the right of the root node. All the children to the left of the root node are less than the root node, and all the children to the right of the root node is greater than the root node. Okay, that's what the binary search tree is. Then the next question is which is better algorithm, O of log n or O of n? O of log n is better. Okay, and what is ML? Which part of which aspect of ML is used in TensorFlow? ML means machine learning, and TensorFlow uses Keras. Okay. What is the algorithm for HashMap? HashMap is a data technique in which the values are mapped to their corresponding keys. We'll have 2 things here. Values will be mapped to their corresponding keys. Okay, and there is a key value pair, and HashMap uses a function to hash the keys. So there will be a function to be deciding which key should be mapped to which value, and find out the index directly or indirectly matching in order to the corresponding keys. And the next question is name all the data structures that you know. So the common data structures are arrays and linked list, stacks and queues, binary tree, binary search tree. Okay, heap, hashing, a graph, and matrix. What are AVL trees? AVL trees are defined as height balanced binary tree in which each node is associated with a balance factor. So what is tree is basically means that you'll have a tree here in which the difference between the left child and the right child will be at most 1, means the height will be at most difference will be 1. This is valid, but this is not valid because height is differing by more than 1. Okay. So the balance factor is calculated as follows: balance factor is equal to left subtree height minus right subtree height's mod value. Okay. So if the balance factor is 0 or 1, then it's a balanced tree, else it's not a balanced tree. The trees which are balanced are known as EVL trees. Next question is time complexity of different sorting methods. So it's very important to know. Selection sort is O of n square, bubble sort is O of n square, insertion sort is O of n square, heap sort is O of n log n, quick sort is O of n square, merge sort is O of n log n, bucket sort is O of n square, radix sort is O of n k, count sort is O of n plus k. Okay. Construct a tree data structure. So how to construct a tree data structure is that behind the tree data structure there is a struct here which is defined as node. Node is defined for each of these. Okay. So what things it has the value. One is the value here, left part it will handle the left pointer as well as the right pointer. So three things are there inside the struct node: int value and node star left and node star right. Next question is how to construct a stack from a queue. Okay, what we are supposed to do is we have to construct a stack. Okay, what is stack is equal to LIFO, last in first out, and queue is nothing but first in first out. So how to construct a stack from a queue, which means that suppose that I have the elements here 1 2 3. Okay, so in queue what happens, 1 came first, it will be out first, then 2 came, it will be out second, then 3 came, it will be out third. And what I want is I want to insert 4 here, and when I insert 4 here, it will be outputting, if it's a queue here, it will be outputting after this one, this one, this one, and then only 4 will be outputting. But what I want is just when I output as 4, at that time 4 should be the first output. So what I will do is I will take 4 in a new array here. The 4 will be inserted in this place, and then each of these will be output. Like first 1 will be output here, then 2 will be output, then 3 will be output here. So what happens here, if I output 4 using a queue, at that time 4 will be the first output, right? Because this was the first one, then this and this came. Okay, so first in first out, but actually it is following LIFO. Okay, that's the algorithm, and you can go to the code here. We'll have two queues. This is q2, this is q1. Initially we'll push whatever we want to push in q2, so in this case it's 4, while q1 is not empty. So whenever it's not empty, what I should do, q2 dot push q1 dot front. So if it is 1 2 and 3, so 1 will be pushed here, then 2 will be pushed, and 3 will be pushed. q1 dot pop, q1 will become empty, so it will have 4 1 2 and 3. After the q2 is initialized, swap q1 and q2, so that q1 means the numbers here will be 4 1 2 and 3. So if it follows FIFO also, the first element to be output is 4, then only other element will be output. But initially but actually this was the last element which was inserted, right? So it's following LIFO by using queues algorithm. Okay, so that's how you convert the queue into a stack. Moving on to the next question, what is dynamic programming? It is a technique used in computer programming that helps to efficiently solve a class of problems that have overlapping subproblems. So what does it basically means is that, suppose that I have to calculate the factorial of a number. Okay, so not factorial, let's see if I want to calculate the Fibonacci. Okay, Fibonacci of 5 is nothing but fib4 plus fib3. What is fib4? Fib3 plus fib2. What is fib3? Fib2 plus fib1. Here also for 3 it will be 2 and 1. So what you can observe is that 2 and 1 is calculated here also, 2 is again calculated here, 3 is calculated here also, and here also. So many repetitions are there. So the answer is getting calculated each time. Instead of that, when it gets calculated for the first time, we will be storing that in a array here. So whenever we need for the next time, we can just refer that array instead of calculation. That's in that way we can solve the problem in a faster way. So that's what dynamic programming is. Okay. So if any problem can be divided into subproblems, which n are divided into small subproblems, then if there is a overlapping among the subproblems, then the solution to these subproblems can be saved for the future reference. So if we save in the past, in future when we need, we can just reference it instead of calculating again. Okay. So example is Fibonacci series. Next question is, what is min heap and max heap? In min heap, the key present at the root node must be less than or equal to among the keys present at all of its children. If that's the case, that's a min heap. If the key present at the root node is the highest one, that's known as a max heap. Okay. So as you can see here in min heap, 6 is there. All the elements here are greater than 6. And coming to this one, this is a max heap here. All the elements written here are less than the element here. Here it's 17, so all the elements present here are less than 17. This is the max heap, this is the min heap. Okay. Moving on, we have the next question. Explain the concept of slow and fast pointers in LinkedList. Okay. So here what we are supposed to do is we have to take an array here, means the linked list here, and after that this linked list has a cycle here. Okay. So what happens, 2 pointers will be taken. First one is f, second is s. So s moves by one direction. Okay, means one here, then again it will move here, then move here, and so on. But fast pointer will move 2 times. Okay, means fast pointer will move from here till here, then again it will move 2 times, then 2 times, then 2 times, and so on. Okay, again it will come back here, like that it will keep on going. Okay. So how can we detect a cycle? In cycle, what happens is s will be coming here for the first time, f will be here 2 times, then s will come here, f will be 2 times, means it's here, then s will come here, f will be 2 times, it will be here, then s will come here, then f will be 2 times, it will be here, then s will come here, f will be 2 times, it will come here, then s will come here, f will be 2 times, it will come here. See, both are coming at the same location. So this is what we can identify if it's a cycle, because if it's a cycle, it fast pointer will again come back in the same row. Okay, right. If it's not having cycle, it will end. Fast pointer will reach the end faster and it will end. But if it's a cycle, it will come back, and obviously it will meet at the same point. Now you might ask, it might skip also, but that's not actually possible. Why? Because let me show you with an example here. So suppose that this is the array list here, and here is the slow pointer, and here is the fast pointer. Okay. So what it can do, if a slow pointer can go here, okay, and fast pointer can go 2 times only. If it goes 2 times, it will meet s. Another scenario, we have 4 pointers here. If s is here and f is here, at that time what will happen? S will go here, f will go 2 times, it will go here. Then the next iteration, s will go here, it will go 2 times, it will go here. So in any case, if f is one distance back of s, suppose that f is here, s is here, if it is one distance back of s and s is going one distance front to it, so how much distance will be between f and the next s? It will be 2 only, right? Obviously it will be 2 only. So whenever the distance is 2, it will catch up s. Okay, so in any case it will come and meet s. So we can detect there is a cycle. If there is a cycle, then only it will come back, right? So that's how we detect the cycle in a linked list using the concept of slow and fast pointer. The next question is, explain the concept of spanning tree. Spanning tree means what? A spanning tree is a subset of a graph G which has all the vertices covered with minimum possible number of edges. Hence a spanning tree does not have the cycles and cannot be disconnected. So if this is the graph here, what are the minimum number of edges to connect all the nodes here? So this is one type, another type, another type. Okay, all are valid spanning trees. Okay. The next one is, explain Bellman-Ford algorithm. In Bellman-Ford algorithm, it helps us to find the shortest path from the vertex to all other vertices of the weighted graph. From one vertex to all other vertices, what is the shortest path? Shortest path that we'll be able to find out using the graph. Okay. So it is done iteratively, increasing one node at a time. So let's see one example here. So let's take the example of a Bellman-Ford question. So if this is the 1, 2, and 3. 1, 2, and 3. If I apply Bellman-Ford, what is the least distance between 1 and 2? It is 1. From 1 and 3, it is 2. The distance between 2 and 3 is 1. Okay. So we have to just find out what is the least distance connecting all the vertices. So we'll check, from here it is this much, here it is this much, here it is this much. So comparing, we'll get to know this is the least distance from connecting all the 3 nodes. Okay. So that's what the Bellman-Ford algorithm does. Okay. So that was about the DSA part, and moving on to the next subject, which is OS. So in operating system, the first question is, explain the Belady's algorithm, in place and out place. Okay, what is Belady's algorithm? Here Belady's anomaly is that the name given to the phenomenon where increasing the number of pages frames results in an increase in number of page faults for a given memory access pattern. So what happens is, pages means just a blank page. Okay, so increasing the pages will reduce the error in daily life, right? If you have more pages, you can write your work more neatly, and error will be reduced, means nothing will be congested in one place, right? But this is the in computer what happens actually, if you increase the number of pages and the memory means the cache here to store the pages, so at that time what happens, the page faults increases, means page faults increases. Okay, that's it. So how does that happen? That's not like in the part of the syllabus, so it's a bit more detailed topic, but this is what the Belady's anomaly is. Okay, and the next question is about the in place and out place. So what is in place? In place means it stores the element in place and therefore does not require extra space. So it stores the elements in the same array itself, okay, just by changing the positions. Out place means it does not sort the elements in one place, but it uses O of an extra space and is called outplace sorting. So to sort these elements, it requires another array here. So by using this array, it will be sorting the final array here, that is known as outplace sorting. Next one is, what is semaphore? Mention its purpose and types. A semaphore is a signaling mechanism, and a thread that is waiting on a semaphore can be signaled by another thread. Semaphore is nothing but it's a lock here. So if there are two processes P1 and P2, at that time there is one resource here. So if P1 wants to access this resource, it will access this and make the semaphore lock as 1. So whenever it is 1, other process cannot access it. Okay, it's busy. Then when this process gets over, it will return back and make it as 0, so that if another process tries to access this one, it can access and makes the value of semaphore as 1. Okay, so that it can access and does the same thing, means while returning it will make it as 0 and free it and return. Okay, so that's what semaphore is for having the synchronization between the two atomic operations. Okay, and instead of the means lock and unlock, we will be using wait and signal. So the wait operation decrements the value of the argument, and if it's positive, if it's is negative or 0, there is no operation performed. So this is the code part here. Wait of s minus minus will happen, and if the signal operation happens, it will do s plus plus. Okay, means just changing from 0 to 1 and 1 to 0. The purpose of semaphore is to just avoid the access of same resource by multiple process. Same resource, multiple process will be there. It does not access every process to means access the resource. Okay, means at the same time. There are two types of semaphores: binary and counting. Okay, so binary semaphore has two values, 0 and 1 for counting, and for locking. Sorry, and counting semaphore has the values ranging from minus infinity to infinity. Okay. Next question is, mention the different types of page replacement algorithms. So first one is first in first out. So if there are pages here, the page which came first in the memory, if it wants to clear, the first page will be cleared. Okay, that is first in first out. And optimal page replacement, in this pages are replaced which would not be used for the longest duration of the time in the future, based on our what probably which page is not going to be used more, that will be cleared up. Okay. So the third one is LRU, least recently used, means which is the page which is least recently used, that will be removed from the memory. Okay, so these were the three type of page replacement algorithms. Okay, the next one is what is the difference between operator overriding and the next question is what is the difference between operator overriding and operator overloading. So overloading occurs when two or more methods in one data have the same method but different parameters. Okay, that is the overloading. Means for example, if there is a class area here, so class area is here, and it has the area defined as s into s, as well as the area defined as l comma b. So in both cases, if the function calls area, it depends on how many parameters are passed. If one parameter, this will be executed, else this will be executed. This is known as the overloading. And what is overriding? Overriding means having the parent has one class, and the child also inherits the same class from the parent, and it will make some changes in it. So that change is known as overriding. Okay, because the same function name from the parent to the class is parent to the child is getting inherited, and the child is making a small change there. Okay, that is overriding. What is deadlock? Deadlock is a situation that occurs when any process enters a waiting state because another waiting process is holding for the demanded resource. Okay, so this you can imagine by the road here. In this road, there is a truck here, and there is another truck here, and a third truck is waiting for this one. Okay, like this and like this. Okay, so what happens, this is waiting for this to move, and this is waiting for this to move, and this is waiting for this to move, and so on. So each are waiting for each other for moving, but since no one is starting first, it will never move, right? So that is known as the deadlock situation. Okay, and the next one is, what is the difference between process and thread? Process is a program under execution, and thread is a small part of the process. Okay, means many thread form a process, many process form a program. Okay, what is virtual memory? A computer can address the memory more than the current amount physically installed in the system. This is extra memory, which is called as virtual memory. Explain OOPS concept. OOP is a concept is object oriented programming system. So it works on the principles of abstraction, encapsulation, inheritance, and polymorphism. So I have to describe each of this one by one. So following are the general OOP concepts. Class is one of the basic OOP types, and object, an object is defined as the instance of class. Inheritance means inheriting from the parent class to the child class, and polymorphism, it refers to the OOP concepts in Java, which is the ability of a variable, object, or function to take on multiple forms. Abstraction, it is the hiding of the data and representing only essential facts and figures. And encapsulation means wrapping up the data and the code into a single memory layout. Okay. The next question is, what is thrashing? Thrashing occurs when a page fault and swapping happens over frequently at a higher rate. Until then, the operating system is has to spend more time swapping these pages. So if the page falls more, it will spend more time swapping the pages. So that is known as thrashing. Okay, what is paging, subnet, and segmentation? Paging is nothing but indexing the values for a particular page here, and subnet means if there are a lot of networks connected to a single network, at that time subnetting will happen. That means it will have the main connection, and it will have subnets among this one. Okay, so the main connection will be handling the subnets among its own, and that is known as subnetting. And segmentation means is a memory management technique in which the memory is divided into variable size parts, and each part is known as segment and can be allocated to a process. So after we have divided this into different parts, and it can be made means whatever the algorithm you want to perform, you can perform, and then it will be can be checked for to the tree means it can be allocated to a process. Okay, so that was about the three things: paging, subnet, and segmentation. So moving on to the next question, what is kernel and OS? OS is the operating system software. Kernel is a system software which is a part of operating system. So inside operating system there is kernel. What does kernel do? Operating system provides interface between user and hardware. Kernel provides interface between application and hardware, software to hardware, hardware to users, like that. Okay, in between kernel is there. What is runtime polymorphism? Whenever an object is bound with a functionality at the runtime, this is known as runtime polymorphism. The runtime polymorphism could be achieved without achieved by method overriding. In method overriding, from the parent class to the child class, we are customizing it, right? The custom form is known as the method overriding. Okay. The next question is, how to achieve encapsulation in Java? There are two techniques: declare the variables of a class as private, and the second technique is providing public material, either setter and the getter methods to modify and view the variable values. You can't directly access, we have to use these functions to the setter and getter functions to access those values. Okay, so that is the way we means achieve encapsulation, the wrapping up of data and the code into a single part. Okay, moving on to the next one, DBMS. The first question is, explain joins in SQL. Join means it is used to combine two or more tables. Okay, so if these are two tables here, order ID, customer ID, order date, customer ID, customer name. So what happens is, customer ID is same here. So whatever the person associated with the customer ID is here, So those people will be sitting here. Okay, so after that the connections will be made here, and after the normal approach is over, then we'll be moving on to the optimal approach. So what's happening here is customer ID is same here, so the connections will be made with the other columns here. Okay, so the join operation with the result will be this one. The next important question: what is the asset properties in DBMS? A means atomicity. So here it means a transaction will happen all at once or it will not happen at all. Consistency: the debate must be consistent before and after the transaction. Isolation: multiple transactions occur independently or without interference. And durability: the changes of an successful transaction occurs even if the system failure occurs. Okay. So these are the four properties of means asset properties are in DBMS. Okay. Next question: what is normalization? Normalization is the process of energizing data in a database. So data is in different forms and different structures, so it is to be well organized. So that process is known as normalization. There are many forms here. The first form is about the removal of multi-valued attributes. So if there is an attribute whose value has comma separated values, that will be removed. Okay. And second NF, remove partial dependency. Whatever values are present in the array here, that should be fully dependent on the primary keys. Okay, if it's partially dependent, that is the 2NF. 3NF, remove the transitive dependency x to y, y to z. There should be no x to y and y to z. Okay, like that. So it can be direct, but it should not form a chain like this. And the last one, remove the multi-value dependency and joint dependency that I have to cover now. Okay. Multi-valued and join is means both are a bit similar here. Multi-valued means in a column there will be multiple values for a single thing, that is known as multi-valued dependency, and the same value will be repeated many times in the column. Okay, so instead of that we can just take this main column here, which reflects this and this. Okay, so that is the 4NF. 5NF means join dependency. If you join two tables, what are the changes to be made here, and what are the changes to be made in these two cases as well. So that is known as the join dependency. So if I apply these dependencies here, the data structure which we have, that will become more organized in a more organized manner. Okay. Next question is, what is the difference between where and having clause? So where clause is used for single entity, having clause is used for group entity, right? So select star from customer, where the condition is applied here. Select stars from customer, group by rating. Okay, having rating greater than 5. So whosoever's rating is greater than 5, those group and the person will be selected here. Okay, so it forms a group here. It's not just restricted to one single thing. Okay, so it's for the group. Moving on to computer networks, the first question is, what are the various website designing tools? So web development tools allows the web developers to test, debug their code. They are different from the website, like builders and IDE will be there. Okay, so web development tools allows the developers to work with a variety of web technologies, including HTML, CSS, DOM, JavaScript, and others. Component as a handled by the local web browser. Okay. So let's discuss each one by one. HTML and DOM. DOM means document object value. So uses the means web page assets, resources, and network information. It uses these three things: profiling and auditing, JavaScript, and debugging. These four things form a successful website. Okay. So web development allows to the developers to work with these things. Okay, and developing it. The next question is, what is a server? A server is a computer program that provides functionality for the clients which has requested it. Okay, so and it's a computer system that provides the resources, data, and services are programmed by the computers, known as the clients over the network. What are third-party cookies? They let advertisers or analytic companies track an individual's browsing history as across the users on any sites and contain their ads. Okay. What are different OSI layers? Application, presentation, session, transport, network, and data link physical layer. Okay. Explain the working of CNN. So a CNN, convolutional neural network, I guess that's the full form. So we'll have three graphs here. So for R, G, and B, three colors will be there, and 4 units are there. So total 16 pixels will be there. Okay, so if we like do the padding here, so what will happen is all these layers approximate value will be written here, and same for the next ones also. Okay, like how in the way we requested. Okay, so like this is performed for RGB, and the patterns are matched with the new strings. Okay, moving on to the next question, what are the protocols of the, used in the network layer? TCP/IP supports the following protocols: ARP, address resolution protocol; reverse ARP, reverse address resolution protocol; ICMP, internet control message protocol; IGMP, internal group message protocol. Okay, so these are the four main protocols widely used. And moving on, we have what is a DMA controller. DMA controller is a hardware device that allows input-output devices to directly access the memory with the lens. Okay, so it's basically a hardware that controls the input-output operations. Okay, so that's all about the theory part, and make sure you solve these problems at least once before going to a next interview. Okay. Hello everyone, in this video we'll be discussing the previous NLSL hub questions which were asked in the interviews. So this is the first question, which is merging of two different trees using both recursive and iterative methods. Okay, so basically what is a tree? We'll be first discussing that. Okay, so let's first discuss what is a tree. Tree is nothing but you'll have a node here which is the root node, and you'll have the other nodes connected to it. So for this question we'll be using the binary tree. Okay, means each node will have two children, left child and right child. Okay, so this is what basically the tree is. Okay, the binary tree. So the question which is asked to us is like if you have two trees here, two different trees, let's make two different trees here. Okay, so we'll have two different trees here. Okay, suppose these two are the trees. Now it has some numbers in that. So since it's a binary tree, it will have the numbers in the, means the greater numbers here and the small numbers here. But for now, just for the example purpose, I am taking random numbers. Okay, like 1 and 2 here. Let's take 3 and 5, 4, 6 and 7 and 2 and 11 and 9. Okay, so we have taken these numbers, and what will be the final result is that, see in the final result what we have to get is the same binary tree we have to get. Like in this node we will create a fresh binary tree here, and in that what will happen is the addition of this one and this one. So what is the addition of this one and this one, which is 1 plus 2? What is 1 plus 2? 1 plus 2 is 3. So in the top we will have 3. Okay, what I mean is in the first node we will have here 3. Okay, means the value. Then what we'll be doing is we'll be going to the here, means we'll be going here and here, and we'll be calculating the sum. So what is the sum of 3 and 5? The sum of 3 and 5 is 8. So we'll have 8 here, and similarly we'll be doing with the left also. What is 4 plus 6? It is 10. So we'll have 10 here. Then here what is 7 plus 11? It's 18. So we'll have 18 here. Then in the right part we just have 2 here, we don't have anything here. So whenever we don't have anything, we'll consider that as what? We'll consider that as 0. So what is 0 plus 2? It is 2. So I'll write here 2. And for 10 here means the left and right part is not there. So suppose that here it was 9, right? So 9 will be writing here, and since the right part of both of this is null, so we'll not do anything. So this is how you merge two binary trees. Okay, so we have to just add up each of these nodes present in the respective positions, and what answer we get is the final tree. So we have to solve this using two methods. First method is the recursive method, and second method is the iterative method. So let's see what is the code here. So in the recursive method, these are the two trees which we have, T1 and T2. Okay, T1 and T2 are the two nodes which have been given. So if you consider the previous example here, let's suppose this is T1 and this is T2. Okay, so we have to merge T1 and T2 using recursive method. Now if T1 is equal to null, return T2. T1 is equal to null means what? Here we have nothing. In this position we have nothing. So what we will do, the final answer will be this tree, right? Because something plus nothing is something. Okay, so in that way we will be solving, and so what we have done here is, if T1 is null we will be returning T2, if T2 is null we will be returning T1. Okay, and we will be defining those two things, and T1 dot val is equal to plus is equal to, sorry, it is plus is equal to, okay, T1 dot val is plus is equal to T2 dot val. Okay, so what you are basically doing here is, we are adding t1 dot val here. Actually we are just storing the answer here itself, we are not creating the fresh new binary tree. Okay, we are storing the answer there itself. So what we are doing, at this location we are adding this answer plus this answer, which is 3, and 3 is getting stored here. Okay, just as this one. So after doing that, what you have to do, you have to move for the left and right. You have to do the same thing for this one and this one. Means this is considered as a separate tree, this also considered as a separate tree. So if you pass this node in the function defined here, merge trees, at that time what happens is this is getting passed and this is getting passed. So whatever was happening for this whole tree is now happening for this one. So this answer will be calculated, then this answer will be calculated, then since nothing is there it will come back, and then it will go to the right things will be calculated, then nothing is there, so it will come back, then again this is done. So after this part is done, we will come back here, then we will move to here, and here it will be moving simultaneously, we will passing 4 and 6, and the same thing will be done for here and here as well. So final answer will be stored in the same tree t1. Okay, so what you are doing, t1 dot val is equal to t1 dot val plus t2 dot val. After that we are calling t1 dot left. What should be stored in t1 dot left? The answer of t1 dot left and t2 dot left. Same thing goes for right also. Finally we will return t1. So this was the iterative method, okay, recursive method. Now let's discuss the iterative solution. In iterative solution we are starting from here, we are passing the t1 and t2, okay, t1 and t2 is getting passed here. Then if t1 is null, we are returning t2 just as the previous one, and if t2 is null, what we are returning, t1. Okay, so this much part is clear. Then we are using a stack. Okay, so let me give you the approach of why we are using stack here. So let's consider the same previous example. In the previous example, what all numbers we had here? The first two numbers are 1 and 2. So we'll have a stack here. In that stack, first we'll store 1, then we'll store 2. After we have stored these two in the stack, this is the first means the element. Okay, in the stack this is the first element. Here again we'll have second element, and in each element we'll have two elements. Okay, so that's how the stack is, and what we'll be doing, we'll be adding these two numbers. After adding these two numbers, we'll be popping it, and that popped answer will be stored back in the same position. Okay, so that's our approach, and after we have popped these two, then we'll do the same thing for the this one, left part and right part also. Each time iteratively we will be storing this answer, then we will be storing this answer, and after that we will move on here and store these two answers as well. So that will be our approach, that's why we have used a stack here. And so let's move on to the code and see what the flow is. So I have created a new stack here, stack tree node. Here is an array, so we are creating a stack array, okay, because we have to store two elements. And st, its name is st, and new stack, and st dot push tree node t1 and t2. So what happens is the tree nodes t1 and t2 gets pushed. Which are the tree nodes t1 and t2? These two will be pushed, means 1 and 2 will be pushed into the stack. After that is pushed, and what we will be doing, while it's not empty, process the nodes. Means if the stack is not empty, something is present here, at that time we will process the node. That's why we are checking first if it's not empty. Now how we will process the nodes? Tree node is, current is equal to st dot pop. When we pop the node, means the first element here, in that two elements get popped. Those two elements, where it should be stored, in an array, because one element cannot store two elements, so we need an array, right? Array is defined here, tree node. So in tree node means this is the data type tree node, and current is the name of the object, means the array. Okay, so current of 0 will have it's getting popped, right? So this is current. In current array, the 0th location will have the first element, and in the second position will have the second element. So that will be stored in current of 0 and current of 1, means the tree node 1 and tree node 2. Now what we are doing, current 0 dot value plus is equal to current 1 dot value, means in the 0th location we are adding is equal to 0 plus 1. Both numbers we are adding and storing in the same position. After we have done that, we will be checking three cases. We have added the values, now we have to traverse either to the left or to the right. Okay, this is the tree t1, this is the tree t2. Now current 0 is equal to null, means if there is nothing present here, and current 1 is not equal to null. Okay, Means what I am trying to say is the left part is null, but the right part is not null. So what will be the answer? The addition of these both, means this will be returned. In other case, if this is not null and this is null, at that time this will be the thing which will be returned. So basically we are returning that which is not null among these both. Okay. If both are not null, we will add and return. Both are not null, add and return. Okay. That will be the three cases which we have to see. So let's first see for the left tree. In left tree, current 0 dot left is equal to null if it's null. Okay, means let's draw a tree here. The left part is null, so we just have the right part here. See here, the left part is null here, as you can see. So current, if it's this is null, at that time current 0 dot left is equal to current 1 dot left. Here what will come? This one will come here. Okay. Else if this is not null, there is something here, but we don't know if this can be null. Okay, there is a possibility that this can be null. In that case, what we will do, we will add this in this position. Before that, we are doing one thing here, this one, current 0 plus is equal to current 1. So if current 1 was not null, obviously it would have been stored here and then it would have not been null. No, that's just for the value, right? So yeah, we are going in the left tree now. So you're checking child node now. If the child node is not null here, means the left part is not null. Okay, there is a left part here, but how can we say that tree is 0? Let's suppose tree 0 and t1. In t0, this is not null. How we are sure that this is not null? See, we came to else condition. Else condition means if condition was true. In if condition, we were checking this was null. So if condition is true, means so if condition is false, that one only we reached here. If condition being false means the left part being null is false. If left part being null is false, that means left part is there. So left part is there in the else position. Now we just have to check for t1's left position, that we are checking here, t1's left position. If it's not null, if this is not null, at that time we have to add these both. So therefore what we are doing, st.push, we are creating new two new elements, adding two new elements in the arrays, current 0 dot left and current 1 dot left, and then we are storing that in the stack. Else in case if this is null, at that time what we will be doing, we will be just returning this one, right? See, finally what we are returning, we are returning t1, not t. In case current 1 is null, what I mean is the t1's left part is null, at that time there is nothing here, but in t0's left part something was there, right? This is the case which we are seeing now. So in that case what should be returned is just this will remain same, because if you add it with nothing, it will remain same, right? So it will just remain same, that's it. Else if both of these are not null, we are adding to the stack, and after we add to the stack, in the next iteration we will pop them out, and after that we will be adding it, right? So see here, after you have pushed the things into the node, means the stack, after you have pushed them into the stack, we will be returning t1. Where is this getting returned? t1 is getting returned here, where we had called the function from. So that will be in the end. Okay, so it will not happen now, but while stack t1 is empty and not empty, if we have added anything into the stack, then in the next iteration what we will do, we will pop it. Okay, in the next iteration we will pop it. So two new elements will come. First these two elements were there. Okay, first these two elements were there. After that what we did, we went to these two locations and then added them into the stack, means 3 and 5 is there now, and then we'll pop this. So we'll have separately 3, we'll have separately 5. Okay, this is current of 0, this is current of 1. Let's see what happens then. Now we are in 3 and 5, so 3 plus 5 8, current of 0 will be 8, and after that we are adding the, means if current 0 dot left, we are substituting if it's null, it's not null. So let's move on to the next case. This also not null, current 1 dot left is not null, means the right tree is not null. So what we will be doing here, we will be pushing those both values, means 3 and 5 will be pushed here. So again when we push that here, same thing goes for the right as well. So after we have done both of those things, it will be in the stack.
this for the left and this for the right, means in the iteration, and first left will be popped out and the process will be done again. After that right will be popped out, again we will be doing the process again. So to give you an overview of the iterative solution, what's happening is, first the stack is created and these two are passed, it's stored in the stack, and after that we are adding them both and storing the answer here. Then what we are doing, we are passing literally the next node itself. Okay, that node itself is getting passed in the stack. This also, the node itself is getting passed into the stack. When these two are getting passed into the stack, after that we are doing the addition operation, and that the answer is getting stored here. Then we are passing the next node of it by using left operator. So this node is passed here into the stack, means that is getting stored. So like that, in each case we are passing the node itself, okay, and making the changes in the respective position. Okay, so since each of these are connected like by left left left, so when we pass something here, the change is actually happening in the tree itself. Okay, so that's how the iterative solution works. And this was all about the first question, which is merging two different trees using recursive and iterative method. The second question is to traverse the binary tree using Zig Zag Traversal. Okay, so let's consider binary tree here, and let's see how to traverse it using Zig Zag Traversal. So we have two nodes here, 2 and 3, and here we have 4, and here we have 5, and here we have 6. Okay, so how do we traverse it using the zigzag traversal? Is that first we will travel like this, we will store 1, then after that we will come in this way, we will store 3 2, and after that we will store 4 5 6. Okay, so this is how we will be traversing in the zigzag way. So let's see how to solve this one. First we'll be writing the code for we'll be taking the vector of vector. Okay, so basically what we are doing is, we'll be having a stack here, it's a stack here. We'll be storing the array here. Okay, an array will be stored here. So for that we'll be using the array of array. So that's why we have wrote vector of vector. Okay, so here what we'll be doing, whatever the first element was, like it was 1, then 2 3, then it was 4 5 and 6. So first what we'll be doing, we'll be taking 1 and storing here, and then when we traverse here we'll be accessing 2 3, but since we have to store in the reverse order, we'll be storing here 3 2, then we'll be traversing this one 4 5 6, we'll be storing 4 5 6 here. So how will this actually happen is that we'll be having another thing like queue. Okay, in queue we'll be first accessing this one. Okay, we'll be accessing 1 and we'll be storing 1 here in the queue. Okay, in the queue first 1 is stored. After, in the first iteration, after the queue, in the queue 1 is stored, and then what we are doing is, we'll be having a flag here to check if it's to be stored in the same order or in the reverse order, as in this case. Okay, for that the flag left to right is used. So if it is true, means we are storing from left to right. If it's true, means we will be storing in the same order. If it's false, means we'll be storing in the reverse order. Okay, we'll see how to reverse the array in the upcoming code. Okay, so while the queue is not empty, this is the queue here which we have. While it's not empty, int size. So we'll get how many elements are there, that number we will get, and we'll create the array of that much size. Means if one element is there, we will create an array of one size 1. And then what we'll do, we'll run a for loop. In that for loop, how many elements are there, that will be storing in this one, and then that will be pushed back to this one. Okay, so as you can see here, what we are doing, first we will pop all the elements of the queue. This is the queue, we had 1 here, that will be getting popped, and the position to find the index value, means if this is the array, are we storing in this order, or from here we are storing. If from here we are storing, we have to store from size minus 1, size minus 1 minus I, we are storing from the back. Okay, so that is getting calculated here. After that, in row of index value, what is row of index? Row is nothing but the new means we are just storing the elements. Okay, we are finding the index value, we are storing the elements. After this gets stored, this has to be pushed back to the queue. So if it's in reverse order, reverse will be pushed. If it's in the correct order will be pushed. Okay, so like that we have to do for all the queue elements. And after we have done for one queue element, means the means we have done for one, right? After that, for 2 and 3 also it is to be done the same thing, right? So what we are doing is, we are pushing the left in the queue first. So left will be 2, then we'll push 3. So when we do in that way, then what happens in the next iteration is, queue is not empty, first 2 will be popped. So when 2 is popped, we'll be storing 2 in the array here. We'll be creating a queue, we'll be creating a array here and we'll be storing 2 here, but we'll not store 2 as such here. We'll be storing 2 from the left. How from the right? How will we know that? We'll know that by changing this one. Left to right is not left to right, so we are changing the flag number. So 2 will be stored from the back. So first 2 is stored, then in the next iteration 3 will also be stored. Okay, but before 3 gets stored, first we are doing everything for 2. What do I mean by that is, first we are storing 2, right? See, this is the queue elements, right? 2 3. Then when we 3 is not as of now, it's not there. Actually 3 is there in the queue, because what we had done was we had pushed the left and the right element, right? So 2 and 3 was already in the queue. Okay, after that we are processing for 2 now. Okay, we had pushed both of these things in the first iteration. In the second iteration we are starting from here. First we will be popping we'll be utilizing 2, and after that we'll be storing the left of 2, which is 4, and right of 2, which is 5, after this one. So 4 5 will be stored, then only we'll move on to the 3. Then what is the right and left element of 3? That will also be stored here. Okay, so the thing goes in this way, and we'll be popping 2 and storing from the left, storing from the right in the first iteration, and we'll be popping 3 and storing from the right in the second iteration. So that will get stored here, and that will be pushed back to the main stack. And after that, when we have all the like these elements in the stack, we'll be outputting in this way. So first one will be output. Here it is 3 2, so 3 2 will be output. Then here it is 4 5, so 4 5 will be output. Then it is lastly it's 6, so this will be popped. Okay, so this is how we traverse using zigzag method. The third question is to detect a cycle in a linked list. Okay, so basically what is a linked list? So in linked list what we have is there will be an element here. Let me zoom out. See, here in linked list there will be elements in this way. Okay, suppose that these are the elements, and this will be connected like this. Okay, so let's write 1 2 3 4 5. Okay, now if there is a cycle in a linked list, how will we detect it? Okay, so the approach which we will be following is, firstly we'll be having 2 pointers, fast pointer and slow pointer. Fast pointer will move by 2 means nodes, and slow pointer will move by 1 node. So let's see what happens when we move them. Firstly, slow pointer will move 1 time, fast pointer will move 2 times, then slow pointer will move 1 time, fast pointer will move 2 times, then slow pointer will move 1 time, and fast pointer will move 2 times. 2 times means this is the next node, and then this is the next node. Okay, so what you see, after that slow pointer is moving, right? Yeah, that will also happen. And after that fast pointer will move 2 times, 1, then 2, and slow pointer will move 1 time. When you see that after slow pointer has moved, if both are in the same position, that means the it has a cycle. Else if it was not the case, like there's nothing here. Okay, let's erase this one, and was like empty. Okay, at that case this will be pointing to null. So fast pointer will reach to null before slow pointer, so that will indicate that the linked list has no cycle. Okay, so we'll be returning like true and false. It will return false if there is no cycle, it will return true if there is any cycle. So let's see the code now. Code will start from here. We are returning the boolean value and has cycle. If it returns false, it has no cycle. If it returns true, it has cycle. And list node head is getting passed, means what I showed you there, the first node is getting passed. Okay, if head is null or head of next is null, return false. Means what? If head is null, there is no linked list, it doesn't have any cycle. If head dot next is equal to null, that means that only head is there, the next part is null, so it has no cycle, so it will return as false. Then we will create 2 pointers, fast and slow. Both will be pointed by head. Okay, means the first node will have fast and slow pointed to itself. Okay, then we will be checking fast dot next is equal to null, and fast dot next is not equal to null. It is not equal to, sorry. If fast dot next means if fast is in the first pointer, if the next value is not null, if the next value is not null, it will be something here. If the next to next value is also not null, then only we will be performing. Else if it's not the case, at that time we will stop the iteration, will come out and return false. Means if null came, what does that mean? it means that list has ended, there is no cycle, right? So that's the check what you are making here. If there is nothing like the next is not null as well as next dot next is not null, at that time fast will move by two directions, so it will be fast dot next, and slow will move by just one direction, so it will be slow dot next. Then we'll check if fast and slow are pointing to the same node. If that's true, that means it's there is a cycle, okay, because that's what happened in the previous discussion, right? If it is pointing to the same direction, that means it's true. In the same place, if it's pointing fast and slow after the iterations, it means that there is a cycle, okay. So that's all the code for the detecting a cycle in a linked list. In the next question, there are three sub questions. The first one is to display the left view of the tree, and the second one is to obtain the subarray of the elements having the maximum sum, and third one is the rain trap. Okay, so let's discuss each one by one. The first one is to display the left view of the tree. So let's draw a sample tree here. So let's suppose there are two elements here and two elements here, one element here and one element here, okay. So this is the tree, and what is the left view of this tree, that's we have to display. Okay, let's write the numbers here: 1 2 3 4 5 6 and 7. Okay, so these are the numbers. If what does left view means is that if we see from the left at that time what is appearing to us, first we are able to see 1, right? First we are able to see 1 here, so 1 will be written. Then we can see 2 here, 2 will be written. Then we can see 4 here, 4 will be written, and then you can see 7 here. So 1 2 4 7 is the left view of the subtree. Okay, so that's how the left view is calculated. And how do we approach this problem? In this problem, as you can observe that we have two functions here. Okay, the first one is the left side view, and second is the left view. Here it's we are just calling the in this the root is getting passed from the main function, and here we are creating a list. After that we are passing the root and the result to the left view, this function, okay, and then finally we will be returning the result. So the entire thing is here, the entire code. So here what we are actually going to do is we will be having two things, the number and the level. Okay, so for this one, what is the number? For this the number is 1 and the level is 0. Okay, and we will also be having a data structure here. We'll be having a stack here. There are two things whenever we encounter a node, we'll be first seeing what is its value. Its value is 1 and the level is 0. So as of now the stack's value is 0, means there is no element in the stack, so the size of the stack is 0, right? Whenever we encounter the node which has the level as 0, that will be inserting in the stack. Okay, so we'll get to know why we are doing this in a small time. So here 1 will be inserted, then where we will go? We will go to the left and the right. First we will go to the left because we need the left view. So when you go to the left, we will do the same thing. What is its level? Its level will be increased as 1, so the value is 2 and the level is 1, and the size of the stack is also 1, so we will be inserting 2 here. So 2 will be inserted here, and then we will be doing the same thing. After 2 is over, we will move to the left and we will see if its level is same as this stack size or not. It's same, so we will be inserting that. So we will be inserting 4 here, and after that we will be moving on to the left. It's nothing, so we will not do anything. Move to the right, then it's nothing, so move back. After we move back, the left part is done. We will move to the right part and we will check the level, and the level is 3, but the 3 but it's already inserted, right? Sorry, its level is 2, 0 1 2, the level is 2 but the stack size is 3, so that means we can't insert this one. Then we will move to the left of this one. It's 7, so the level is 3 and the size is also 3, so we will be inserting that, which means 7 will be inserted here. And yeah, we will check its left and right. It's not there, we'll come here, we'll check its right, it's not there, we'll move back. And since its left and right is done, we'll move back here and we'll come here and we'll check the level. Level is 1 but the size is 4, so it will not be considered. So we'll come here, we'll check its level, that will also not be considered. We'll move back and that's over. So what we got is 1 2 4 7, and that's the left view of the tree. So let's see in the code how it happens. In the first, what we are doing, we'll be seeing if the current is null, means if it has no left child or right child, at that time it should return as null, right? So that's why we are returning null. Else if we will check the depth, current depth is same as the size of the array. If it's same, then we'll be inserting that value in the array. Okay, and we'll be calling the left first by passing the left part here, and the result array will also be passed, and the current depth plus 1 because we are moving one level down. So current depth plus 1 should be passed, and after the left is over, we will be checking for the right, so we are passing right. Okay, so this will be done recursively, and in the result array, in the result stack, we'll have all the elements in the if we approach from bottom to up, it will be like the left view, right? So that was about the function to display the left view of the tree. Let's move on to the next one, which is maximum sum subarray, maximum subarray sum. So let's consider an example here. Let's take an array. This array, first we have -1, -2, 4, -1, -2, 1, 5, -4. Okay, so in this array what we'll be doing, first we'll be starting from here. Okay, we'll be starting from here. If the sum is less than 0, we'll not consider it. If it's equal to 0 or greater than 0, then only we'll consider. So sum is still 0, we will not do anything. Again -2, 0. Here it's 4, so the sum will be 4. Then we'll come here, it's -1, so what is 4 minus 1? 3. 3 is greater than 0, it will be kept as such. Then we'll come here again, -2. 3 minus 2 is 1, it is greater than 0, it will be kept as such. Then it is 1, 1 plus 1 is 2, it will be considered. 2 plus 5 is 7, that will be considered. 7 minus 4, 7 minus 4 is 3, but 3 is less than 7, right? So we'll be not considering that, we'll be considering 7 only. Okay, we'll be adding up each sum and we'll be checking what is the previous sum. If it's greater, we'll be changing, else if it's lesser. Now the current sum is lesser than the previous sum, we will not consider the current sum, we'll consider the previous sum. Okay, so in this way we will be getting the maximum sum. Here the means the basic logic is that we don't want to carry the negative sums because we want the maximum sum. If we carry -1 also in the upcoming iterations, it will obviously reduce the sum. I can better have 0 than having -1. I will get a better answer with 0 than with -1. So that's why I am ignoring whenever I get the cumulative sum as minus negative value. I will not consider that. Okay, so that is known as cadence algorithm. So this is the code. In the code, first I will have the nums array here, and the sum will be initially 0. I'll have maximum as nums of 0. What is the first element? That will be the maximum, means -1 here, and then in the loop I will be traversing. Each time I will be doing sum plus is equal to nums of I. So when I do sum plus is equal to nums of I, it will be like -1 first, and I will be checking if sum is greater than max I. It's not greater, so if sum is less than 0, yes, it's less than 0, so make sum as 0. So fresh new sum will be 0. Again I will check for the next iteration, it is -2, so -2 will be added here. Again it's less than 0, I will keep it as 0. Then I will move to the next iteration, it will be 4, so it will be 0 plus 4, it will be 4, it's greater than 0. So yeah, sum is greater than the maximum element, so maximum will become 4. Now maximum is 4. Then I will keep on adding until I get the positive numbers, and in the maximum I will be keep on checking if the next sum is greater than the previous sum. Then I will consider the next sum and store in maximum, and finally I will return the maximum. Okay, so this is how we solve the maximum sum subarray question. Next one is the rainwater trapping. So the basic idea behind this is, let's take an example here. So this is the thing which you will be given. You will be given with the heights of each of the in the street, what are the heights of the objects, and after that you have to see how much rainwater can be trapped. Okay, so if you try to trap the rainwater, where all it will be trapped? Here it will be trapped, right? How much water will be trapped here? This much, and here it will be trapped this much. Okay, here 1, and here 2, and here 1, and here it will be trapped as 1. So how are we getting to know that how much rainwater is getting trapped? The first thing is we need to know what are the how much rainwater is trapped at each location. Okay, what I mean is at each location, at this point how much rainwater is trapped? 0. Here how much is trapped? 0. Here how much is trapped? 1. Here 0, 1, 2, 1, 0, 0, and 1, 0, 0. This is the individual places where the rainwater is trapped. If we get these answers here, at that time we can just calculate the final answers, right? Here 1 is trapped, and here 1 plus 2 plus 1, and here 1. So what will be the answer? 6. So the answer is 6, that will be returned. Now the question is that how can we get this one? That's the main question. So to get that one, we'll be using two arrays here, suffix array and prefix array. So let me tell you why we are using suffix array and prefix array. Okay, so let me erase this one. So in suffix array and prefix array, what we'll be doing, if you observe carefully, how much water is getting trapped here? In this position, it is 1. How did we get 1? We got 1 because we are considering the maximum height building in the left part and the maximum height building in the right part. Okay, which is the maximum? It is 1 here and the maximum is 2 here. Then you are selecting the minimum among these two, which is the minimum 1, and minus what is the height of this one? Height is 0, so 1 minus 0 is 1. So here I am getting the answer as 1. Let's consider another example. Let's consider for this one. Let's consider for a height one. Okay, so here the height is 1. Okay, this for this one, and the height is 1. And what is the maximum in the left? The maximum in the left is 3. Okay, and what is the maximum in the right? It is 2. So which is the minimum among these two? Minimum is 2. So write 2 here, and then subtract with the height of this one, minus 1. That will be 1. So this is what our approach will be. We will be following this approach to find out how much water is trapped in each location. We can follow the we can use the for loop to find out which is the in the left which is the maximum, right which is the maximum, but that will take a lot of time. The optimal solution is that what we'll be doing, we'll be keeping two arrays here. First is the prefix array and second is the suffix array. In prefix array we will be storing what is the maximum height in the left, and in suffix array we will be storing what is the maximum height in the right. So for this current position here, what is the maximum height in the left? It is same as this one only, 0. Then for this one it is 1, here also it is 1, here it is 2, 2, 2 and 2, here it is 3, 3, 3, 3 and 3. So whichever element you take, the maximum height is given by the prefix of I, right? The same thing we will be doing for the right also, but we will be starting from the right. Okay, means for the suffix array, maximum height in the right is 1, here it is 2, 2, 2 and 3, 3 and the rest of the things will be 3 only. Now we got what is the maximum height of the building in the left and as well as in the right. So if whatever we want to consider, like for example if you want to consider this one, how much water is stored on the top of this building. Okay, what we'll be doing is we'll be using this one, 2 and 3. These are the maximum in the left and the right. Which is the minimum among these two? This is the minimum. And what we have to do after selecting the minimum, subtract with the height of the building. So when we subtract with the height of the building, we will get how much water is stored here, which is 1, right? So that's how our approach will be. We'll be using a for loop to traverse from here to here, and each time we'll be storing the sum. Means for this one, what is the answer? 0 or 3, which is the minimum? 0. 0 minus 0 is 0. So here it is 0, and here it will be 1. Here also it will be 0. How? The minimum among these two is 1. 1 minus 1 is 0. Again minimum among these two is 1. 1 minus 0 is 1. So 1 water is the 1 liter water is stored here. Like that we'll be doing for each of these, and we'll be adding up what are the non-zero elements. Okay, so that will give us the final value of how much water is stored. Okay, so that's what our approach is. So let's see the code here. In the code part, firstly I am taking initializing the variables which are needed, like the sum, max left, max right, and this is the prefix array, this is the suffix array. Then we'll be traversing one by one for the finding the which is the max, means initializing the prefix array. So for that we will be traversing here for loop for I is equal to 0 is less than value dot size. If the value is greater than the max left, prefix of I should become the value and maximum left should become the value. Okay, like that we will keep on doing, else the prefix value is the maximum left value. If a new value comes in the left which is more greater, that will be stored in the prefix as well as in the max left. Else if it's a smaller value, the previous max left value will be stored in the new prefix, the prefix value for the new building. Okay, like that we will do for the right one also. After we have done for the left and right, then we will be moving on to the this for loop. Here we will be storing how much water is there, so it's calculating how much water is there. For that, first I have to calculate minimum among prefix of I and suffix of I. At that position, the three things were there, right? Here I am calculating which is the minimum among these two and minus this one. So minimum among prefix and suffix minus what is the height of the current building. That will give me how much water is stored on top of that, and that will be added to the water. So after we get over with this for loop, we'll have in water the total water trapped by the buildings. Okay. Moving on, we have the next question, the code for binary search. What is a binary search? We'll have an array, for example. If you have an array like this, all the elements are in a sorted order. Okay, so if you are searching for an element, like suppose here the elements are from 1 to 10,
and from here it is 1 to 20. If you are searching for the element 17, so we need not search here, we'll just search in this part, right? So what we are doing is will be using three variables. This is the left part, this is the right part, this is the mid part. Mid is nothing but L plus R by 2. And if you don't get the element in the middle part, what we'll be doing is either we'll be searching here or here. So if the element which you are searching is greater than the middle part, then we have to search in this part. So we'll just have to be concerned with this array. So L will become this part, and M will be L plus M by 2, L plus R by 2, which will be here. Okay, so like that we'll keep on doing. If the element is smaller than M, we will be searching in this part. So what changes we'll be making is R will come here, L will be here, L will be here only, R will come here. So that's what the binary search is. Let's see how to write the code for it. Firstly, if R is greater than L, the right part should be greater than left part, then only we'll be searching it. Mid will be L plus R minus L by 2, that is the same as L plus R by 2. And if current of middle is equal to x, means the array's middle part is equal to x, which you are searching, then return the mid, which is the index. Else search in the if the element is greater than the element which is in the middle, which we have found out, this is greater than the element which we want to find. If this is greater than the element, that means element lies in this part, right? So what we will do is we will be keeping L as such, but h will become mid minus 1, mid minus L. Okay, sorry, mid minus 1. So this is mid minus 1 will be this one. So this is the L and this is the R. It will become L and R like this. In the other case, we will be returning, if it's greater, then it will be mid plus 1 and R. So R will remain as such here because you want to find in this part, and L will become this one. This is what mid plus 1. Okay, so that's what the code for binary search is. And the next question is code for keeping the count of every integer in an array. Simple, we'll be using a map. Here we have the int and int. It will be mapping from int to int, and the map name is count keep. Okay, so we'll be traversing through the array. Suppose that the array is ARR, and we'll be traversing through each array, and whatever be the element of ARR of I, means it will be 0, 1, 2, whatever the element is, we'll be accessing this element, and that frequency will be upgraded. So in the map, for each element the frequency will be upgraded, and finally in the count keep we'll have all the elements which are present in the array, along with mapping to how many times those has occurred. Okay, next one is AVL trees. AVL trees is nothing but a balanced tree. Okay, means the balancing factor should be at max, it should be 1, the mod value should be 1, means when you subtract the left height of the left subtree and the right subtree and take the mod value, the answer should be either 0, -1 or 1. Okay, means if you take the mod value, you will get either 0 or 1. So in this case it is -1. How is it -1? Because I am subtracting 0 minus 1. So what is 0 minus 1? -1. But here it is not balanced. Why? Because it's -2. Why you got -2? Left part is 0, right part is 2. So 0 minus 2 is -2. So to balance that, what we'll be doing, we'll be keeping it as such here, and we'll be rotating this here. So we'll have 1 minus 1, 0. That's a balanced AVL tree. So that's what the AVL tree is. And the next question is about the tree traversals. There are mainly 4 types of tree traversal: pre-order, post-order, in-order, and level order. So pre-order, post-order, and in-order are DFS, coming under depth first search, and the BFS has the level order traversal. So let's discuss each one by one. In pre-order traversal, suppose that this is the tree here. We will be first traveling to the root node, and then printing the root node, then we will travel to the left, then travel to the right. Means we will print this one, then travel to the left, again we will print this one, travel to the left, then again we will print this one, right, left is not there, we will come back and see if right is there, right is also not there, we will move back here. Then since left part is done, we will move to the right part and do the same thing here also. We will move back here and move to the right and do the same thing here also. So that's the level pre-order traversal, NLR. Okay, so here first we are checking if it's null. If it's not null, we will be printing the node node.data, then we will move to the left, then to the right. Okay, same thing goes for the post order as well, but the order is different. Here left, right, and n is there, and in the in order traversal we'll have L and R. So we'll have left, then we'll print the node, then we'll have the right. Okay, coming to the level order, it's a bit different, because in level order how we'll be doing is, suppose that let's consider an example. We already discussed this one in the previous question, so let's revise what is in the level order traversal. So here we have some elements like 1, 2, 3, 4, 5, 6. In level order traversal, first I will travel like this, I will print 1, then I will come back and travel like this, then I will print 2, 3, then I will come back and print 4, 5, 6. So the approach of the question will be as follows. We will have a queue here, as well as we have the final result here. Okay, this is the final result, let me mark in red, and this is the queue which we will be using. Okay, so whenever we encounter an element, we will be storing that in the queue, and
After we have stored that element in the queue, we will be making an array of this much, means how many elements are stored in the queue, that much size array we will be making. So one size array we will be making, and we will be popping this out and storing it here. Then we will be storing the array here. So firstly it will be 1 here. Then coming to the next one, left part is 2, so I will store 2 here, the right part of 1 is 3, then 1's part is over. Okay, then will come how much is the size 2, so I will create an array of size 2, 2 and 3 will be there. It will be popped here eventually, and when I pop 2, before that I have to store 4 and 5, because left part is 4 and right part is 5. So 4 and 5 will also be stored here, and then I'll pop it and I will be storing that in the array which I made here. And after that, coming to 3, the left part is 6, so I'll be adding here 6 and then I'll be exiting it. Okay, now here it is 654, so before that this will be stored here 2 and 3, and then 654 is there, so 654 will come here. Means after making the array, popping each of these and checking if there is any child in the left or the right parts of each of these, it's not there, so this is the final array. We will be storing the 4 5 6 in a new array created 4 5 6, and this will be stored here. Okay, so what we have 1 here, 2 3 4 5 6, right? So that is the level order, 1 2 3 4 5 6. Okay, so that's the basic means what will be the approach of our question. So let's see the code part to get a better understanding. See here in the code part, first what we are doing, firstly we have we are creating an answer array, which is the final array, I guess, which we are returning. Yes, that's the final array in which the different arrays will be stored in this way. Means how many elements were there in each iteration, that many number of that much size arrays will be stored here. And if root is equal to null, return answer, else we'll be creating a queue for storing each time how many elements are getting popped out. So we'll be pushing the root first, which is 1 here. If queue is not empty, then only we'll be doing. If queue is empty, that means the whole input is over. So what we are doing here is we are creating another level is nothing but a small array which we are creating, same as how much elements are there in this queue, and to store those elements here, and then we'll be pushing this finally into the answer queue here, right? That's what we did. So let's see what happens further. So I is less than size, so we are just accessing how many elements are there in the queue. So how many elements are there in the queue, that will be accessing one by one. So first one will be accessed, one is stored here. We'll be doing queue.pop. Once right will be pushed back to the queue, once left and once right will be pushed back to the queue. That means 2 and 3 will be pushed here, and then level.push node value. What is level.push? Level was the array which we had created for storing that in the answer array. So here what will be pushed? The element which I have, which is node 1. Now I'll see that if the size is over, so obviously I will come back and the answer will be pushed back here. So in the final answer, the level array which I had here, that will be pushed here. Then coming to the next iteration, what will happen? I have 2 and 3 in my queue, so the size of the array will become as 2 and 3, and each time in the queue I'll be storing for 2 it is 4 and 5, and for 3 it is 6. This will be stored here first, and then the left and rights are stored. Then I'll be pushing back the node value. So first I'll be pushing 2, in the next iteration I'll be pushing 3, then only 6 will come. Okay, firstly 4 and 5 will be there. After that is done, I'll be pushing back into the final answer array in the second place, and after that is done, I'll be again doing the same thing for 4 5 and 6. Since no children are there for 4 5 and 6, that will be the last one. I'll have 3 array here, and that will be stored here in the final answer. Finally I'll be returning the answer. So this is the code for the level order traversal. The next question is the least common ancestor. In that we'll have a tree like this, as you can see here. So if we consider 2 nodes here, 2 and not 2, let's consider 4 and 6. Which is the common ancestor between 4 and 6? 4's ancestor is 2, and from 6 we get 5, then we get 2. So 2 is the common ancestor, least common ancestor between 4 and 6. So how we'll be approaching this question is, firstly we'll be starting from here, starting from 1, and we'll be moving left and right. Okay, and what we'll be doing is, along with the root node which we are currently present at, we will be passing P and Q also. P and Q are nothing but the nodes which we want to find out, like 4 and 6, the common ancestor between 4 and 6. So 4 is P and 6 is Q. So what happens is, when we reach from here, when we move to the left and to the right, then again we move to the left and move to the right, and at this position there is nothing here, so it will be returned as null. So null will be returned, and from here also null will be returned. So we are getting 2 nulls here. When we get 2 nulls here, so what should happen is, if both the things are null, means if left is null, return right, else if right is null, return left. So in both the cases we will be returning null from here, so what will be returned from here is null. Okay, so from this case it will not be actually returning null, because 4 is the number which we want to find out. So when we want to find out the number which itself is the p or q, at that time we will be returning root. If root is equal to p, return root. That means p will be returned from here. Sorry, null will not be returned. Null will just be returned from here. Okay, here and here. But from here 4 will be returned. So 4 is getting returned from here, and same thing goes for here also. 6 will be returned from here. Okay, and from here, since left is null, from the right, since right is null, from the left 6 will be returned. So when 6 is returned and 4 is returned, if both of these are returned, means both we are not getting null. So what does that mean? If both we are not getting null, it means that we will be returning root. Okay, so therefore we will be returning root, and which is the root if we get both not null, that is the least common ancestor, which is 2. So basically we are just traversing until we get the both p and q. So we will be returning p and q. When we get both p and q, means both not null, we will be returning to which it got to which the answer was given as not null. That is our answer. Okay, because there is no other possibility of returning different numbers, so not null only means p and q. Okay, the next question is finding the largest sum in an array that such that no number should be adjacent. Okay, so let's take this example here. In this example I have a num array here as well as the DP. Okay, DP is dynamic programming. Okay, so here what I'll be seeing is I should find out the maximum sum where no two numbers are adjacent. So if I just consider this much if I just consider this much, what is my maximum sum? Obviously it is 5 only. So what I will do is I will be writing here 5. Till this point it is 5. Then if I consider both of these numbers like 5 and 6, which is the maximum sum, either I can take 5 or I can take 6. So what I will take? I'll take 6. So till this point it is 6. Now after that, if I take 3 of them, either I can take 10 and 5 or I can take 6. So what I'll be doing is I'll be adding 10 with 5 and checking if it's greater than 6, I'll take that, else I'll take 6. So 10 plus 5 is 15, it's obviously greater than 6, so I'll be taking 15 here. If you consider 4 here, at that time what is my option is, either I can take 100 plus what was present here, or I can take what is present here. Okay, so 100 plus 6 is 106, I'll take 106 here, that is my bigger answer than taking 15, then taking 15. Yeah, 15 is more or 106 is more, so I'll take 106. If I take till here, at that time what I will checking is this this value plus what was present in the I minus 2 value, that is greater or this is greater. Obviously this is greater, so I'll be taking that, I'll be keeping here as such 106. Then if I take all, I'll be adding this one with I minus 2 is this one, that is greater. If I add 7 with 106 is greater, or just 106 is greater. Obviously 7 with 106 is greater, so I'll write here 113. Okay, that same thing is done in the code part as well. So here we have the DP array first. Okay, and this is the nums array, and I'll be traversing from 0 to num size, and each time what I will be doing, I'll be for the first two values I'll be assigning which is greater value, like here I assigned 5 and 6. After that I'll be checking which is greater, nums of I plus dp of I minus 2 or dp of I minus 1, if the previous value is greater, or the current value plus dp of I minus 2 value, two values previous, which is more that I'll take and store in dp of I. So the last answer of dp will be the answer which I need, that's the maximum sum. Okay, moving on, we have the top view of the binary tree. So what is the top view? Top view means if I look the tree from the top, what all I can see. The final answer should be, I can see 6 from here, I can see 6 from here, then I can see 4 from here, 1, 2. So the answer should be 6, 4, 1, 2. How do I approach this problem is, for each level, for each you will have a level here. It will be 0. If I travel to the left, it will be -1, then again -2. Then if I travel to the right, it will be 1. Okay, in that way we will be doing. So so firstly I'll be taking 1 here, and it will be stored in a queue as 1, 0 level. Okay, after that the left and the right will also be stored. It is 4, -1. The left one, the right one is 2, 1. That will also be stored. After I process this one 1, 0, in the map I will store For the 0th level, that's the first level I encountered, so 0 is empty. That in the map it will be stored as 1. And for the next one, for the 4, what I will do, -1 is also encountered for the first time. Then I'll pop this one and I'll write -1. It's 4. 4 is the first number for -1 level. Then I'll store this one as well, like 6 and -2. So I'll have here for -2 I'll store as 6, and for this is 0th level. So for 0th level it's already 1. I'll not do anything for 5. So in that way I'll be getting the first means the element which I'm getting in the each level. Okay, so when I pop this one, like 2 and 1, so for the 1 also it's not stored, so 2 will be stored here. So when I get all these numbers here, then I'll be printing these numbers, means I'll be iterating to the map and I'll be printing the second element of it. Means this is the first element, this is the second element. Let's see the code part here. Let's see the code part here. In the code part, I have first taken an answer array, which I'll be returning at last, which is the answer array. Answer array is nothing but in the map what all I got in the second place, that I'll be storing in a different array, that is known as answer array. Okay, and here if root is null, I'll be returning the answer. Means if the question what they gave is nothing, so the answer is nothing, right? So I will return nothing. Then if it's like I have to use a map, so I'm creating a map here. Then I'll be using a queue to store the pair, which is node star and int, which is the node I'll be storing here, as well as the level which is present here, that I'll be storing. For that I'm creating a queue. I'll be first pushing root comma 0 because root is present at the level 0 while queue is not empty. And what I'll do, auto it is equal to queue dot front. I'll just pop this one. This one will be popped. It will be stored in it. In it, then two things are there. In the first thing, it, what is there, the node value. Second it, what is the thing, the link value, the level value. So I'll be coming here, and after I pop it, means after I take it in auto I, the front value of queue, then I'll pop it, I'll make the queue empty. Then the node will be the it dot first. In the node it will come it dot first, the first thing among the it, and the second thing among the it will come in line. And after that is done, I'll be searching if line is already initialized in the map or not. If it's not initialized and the map got ended, at that time I'll be initializing the map with what is the data of the node. So if I get here like 0th level, it's not initialized in the map, I'll initialize 0th level with the data present here. Okay, after that is done, I'll move I'll be adding the left value of the node to the line, and when I add the left value, I'll do -1, line -1, and if I want to add the right, I'll be adding the right and doing line +1. Okay, so in the queue two more values are added, the left value and the right value. Okay, so in the queue two more values are added, left value and right value. Okay, so in the next iteration what will happen, again it will go back from here, again it will go before that it will take this thing, I guess. No, it will go back. Okay, it will go back and it will search for this one. Again the while loop is not over. While it's not null, it should happen, right? While it's not null, while queue is not empty. So we have pushed the left and the right element, so queue is not empty, and then again we'll move in this direction, and again we'll be doing the same thing. We will be popping each. I will be storing the value in the queue, and again I will be storing which is the left and right of that second element. Okay, so in that way I'll get all the initializations here for the values of levels, different levels, -1, -2, 0, 1. So it's a sorted map. So in that way I'll be accessing each of these element and in the order wise, and then in the order wise means I'll be starting from here and accessing all these -1, -2, -1, 0 and 1. So in that way I'll get the answers in the second element. So I'm getting the answer in the which element, second element, right? So in the second element I've written here, so it dot second will return me the second, which will be stored in answer. Finally I will be returning the answer. Okay, so in answer the sequence of the top view will be stored. Okay, the next one is the reversing of linked list. So let's make a sample linked list here. Okay, to reverse a linked list, what we will do is, firstly it will be like this. We just have to change it to in the reverse way. Okay, so for that first null will be here, null will not be there, null will be here initially, and finally null will be here. So what I will do is I'll take a dummy pointer here, and then I'll be pointing this node to this one, and this will be the head and this will be next. Okay, after I pointed this to this one, then what I'll do, I'll make the dummy node here and the head node here, and then I'll point this to this, again I'll point the next to here. So what will happen after I have done all those things, I'll get a link like this, and this link will be broken here, and I'll have the dummy node here, dummy node here, and the head here and the next here. So what will happen again, I'll do head to dummy node, and I'll be passing the head. I'll be changing these three positions. Null next will come here, head will come here, and dummy node will come here. And again I'll be doing the same thing, point this to this, and again I'll keep on doing. Okay, I'll keep on doing until all the things are changed and the next and the head reaches null. If the next and the head reaches null, that's my endpoint. Okay, so that's the code here. While head is not null, we'll be doing the things. Okay, and we are creating a next pointer here pointing to head or head of next. Okay, so wherever head is pointing to, head of next is this one, right? If three nodes are there, if this is head, okay, if this is head of next should be pointed by next, so this will be next. Okay, after that head of next should be new head is nothing but the dummy node. This is null node, this is dummy node is equal to head node. Okay, new head. Okay, so head of next is equal to dummy node, so head of next will become this, it will point to the dummy node. Then I'll change new head to head and head to next, so new head to head and head to next. Like that I'll keep on doing until I reach the end. When head is equal to null, it will be the reverse linked list. Okay,
The next question is about BFS traversal. So what do you understand by the term BFS traversal? BFS means nothing but breadth first search. Okay, to give you an overview of what breadth first search means, consider this graph here. Here you have one node and that is connected to one node here, and this is connected to two nodes here. Okay, so in breadth first search, what will happen? It will go to all its neighbors. How many neighbors are there? One neighbor, so it will go to here. Now it will go to all its next neighbors, so it will go to here and then it will go to here. Okay, now suppose that this also had some neighbors here like this. Okay, so what would have happened is it would have gone here, then from here it will have gone here and here. Okay, and it will have gone all to this at the same time. Okay, it is different from depth first search, because in depth first search what will happen, it will go here and then it will go either here or here at the time only one. Okay, but in breadth first search it will visit all its neighbors parallelly. Okay, so in depth first search you will go like this, then from here you will go to like this. Okay, then after that gets over, you will come back and then you will go like this, then after that gets over, you come back and you will go like this. So that's what happens in depth first search. Okay, so how you'll be solving this question is that for breadth first search you'll be getting two arguments, which is int v, number of vertices, and a vector. Okay, means adjacent nodes, means it stores what are the adjacent nodes present in the array. Okay, two things you have got, number of vertices and the adjacent nodes to all these vertices. Okay, and you'll be creating a vector int which is BFS, and you'll be creating a vector int which is visited will have like initially all zeros. Okay, and it will be initialized till index number v. Okay, so this is the for loop. That's all what you'll have to implement in this program. You'll have a for loop which is running from 1 till v. Okay, so it will start from 1 and it will run till v nodes. Okay, and it will check if that node is visited or not. If it's not visited, then you will create a queue and you will pin it. Okay, so here a queue will be created. If the node 1 is not visited, 1 will be placed here. After that you will be making the visited of I. Visited of I means there is a visited array, and the visited of I is this one. You will make it as 1. Okay, means it's visited. While queue is not empty, at that time you will do the following operation. While queue is not empty, you will take this node and initialize it to node, and node will have this value whatever is here. After that what you will do, bfs dot push back node. Whatever node you have visited, you will be pushing back in the bfs array which we have made. Okay, so one will be here. Now what you will do, you will be checking all its adjacent nodes, whatever is there in the adjacent nodes of which node I have passed here. The ones all adjacent nodes, so suppose that 1 is here and 2 is here, 3, 4, so all its nodes are being visited. Okay, then if it's not visited, q dot push. If this is not visited, again in the queue whatever is not visited yet, that will be pushed here, and then 3 will be pushed, and then 4 will be pushed. So what's happening is 1 is visited and all its neighbor are being visited. Okay, and after that whenever we visit one of the nodes, we'll make it as 1 and I will move on to the next one. Then we'll move to 2, again we'll pop it, again we'll come back here and we'll check all of the 2 adjacent nodes, and then we'll be visiting each and we'll be pushing it in the queue, and then we'll be seeing if it's possible. If you have not visited it, we will visit it. Okay, like that we'll keep on doing until queue becomes empty. Queue will become empty and only when we have visited all of its neighbors. Okay, that's all what you have to do in the BFS traversal. And coming to the DFS traversal, here we have the arguments node and a vector visited and a vector adjacent and the vector store DFS. Okay, so how we'll be using this is as follows. Okay, in DFS what happens is, see, this is the code for DFS. It's a pretty simple one. Here firstly we'll be starting from here,
we have v and the adjacent vectors. We will be creating a store DFS as we have created BFS in the previous question, and here is the visited ones. Now in DFS what we have to do is, suppose that this is the graph here, and in DFS we have to check for each of the we'll start from here, we'll start from here for from every node we'll start. Okay, so for that only it's running from I to V. If it's not visited, we will call the DFS. Okay, so let's see what's happening when you call the DFS for one of the nodes. When you call for the DFS, it will push back the node which is in the store DFS. Store DFS stores the order of the DFS traversal. Then we will make that node as 1 in the visited array. Okay, then we are traversing each of the adjacent nodes, and whenever the adjacent node is not visited, we'll again call the DFS. Like if this is the code here, instead of BFS like pushing all the nodes one at the same time, what we will do, if we'll check this, if it's not visited, we'll check this, we'll come back to the first node again. If it's not visited again, we'll check this, and when all of it is over, then we'll come back here, and then we'll go to the next one. See, this is the for loop, right? First it will access this one, then it will access this one, then when it's over, this for loop will be over again, it will come back to where it was called from, and for this it was called. So if this is over, then it will go for this one. Like it was over for this one, then it will go for this one. Like that it happens. Okay, so that is the code for DFS traversal. Coming to merge sort means we'll be having an array here. Okay, we'll be dividing this into two. So we'll have a half array, and we'll be dividing these both also into two until you get a single element here. Okay, then what we'll be doing, when we get a single element here, we'll be seeing which is the greater element. If this is the greater means if you are sorting in an increasing order, at that time what we'll do is, which is the smaller element among these two, we'll place that first, then we'll place the next one. Okay, after we have done this one, again we will check with this one, then this with this one, whichever is the smaller element, that will place first, then we'll check this with this one and this with this one, then whichever is small element will place. Like that we'll get four, another half we will get four elements. That two also will be compared, each by having two pointers, whichever is smaller in the pointers, that will be placed, and that pointer will be moving forward. Like that we'll keep on doing until we merge the sort the whole array. Okay, this is known as merge sort because we are merging the array after breaking it down. Okay, so here a few things are needed, like the array which is needed here, and s is needed starting, and the e is needed for ending. Okay, and mid is equal to nothing but the size by 2, so we are just cutting it into half, right? So we need the mid value. Len1 is nothing but till here. Okay, mid minus s plus 1 is nothing but this location, and len2 is nothing but e minus mid means this location. Okay, so you're just getting how much is this length and how much is this length. Okay, and after that the first where it's pointing to new of means this is a pointer for the first array first half, and this is the pointer for the second half. Then we'll be called from 0 till mid array mid index plus 1 from the main array. This much values are copied in this array, and this much values are copied in this array by using the two for loops. This is the first for loop, and this is the second for loop. Okay, two index values are copied, we have done the half. Okay, now what we'll do, we'll take the index values 0 0, and then we'll be starting to compare. Now when index 1 is less than len1 and index 2 is less than len2 means we'll be starting from here, two pointers are here, while this pointer is not crossing this one, and while this pointer is not crossing this one, at that time we will check which is smaller, first index is smaller, second index element is smaller. Whichever is smaller, at that time we will apply that index. If 1 is smaller, we'll apply that index here. If 2 is smaller, we will apply that index here. Now sometimes it can happen that both the elements are not equal. This pointer will reach here, but still some elements will be left here. At that time these elements are to be copied in the main array, right? So what we will do is, we will be using while loop. If index 1 gets over first, this whatever values are present here, that will be means if index 2 gets over first. Okay, because if index 2 gets over first, index 1 will not still reach len1. See what I mean is, if index 2, this is the index 2, if it reaches null first, it have not reached null here, so whatever is left here, that will be copied in the main array. Okay, same thing goes for index 2 as well. If index 1 has reached the null and index 2 is still less than len2, whatever present is present here, that should be copied into the main array. Okay, so that will be copied. So this is how you compare and merge, but before that you should have divide the array into two parts. Now how is this happening, I'll be explaining that. So we'll be writing two codes, one for the merge and another for the merge sort. So first we'll be checking if s is greater than or equal to e, then return it. Else if we'll be calculating the middle value, and we'll be calling the left part. After we have calculated the middle value, we have to call the merge sort for 0 till
S is the starting point and M is the middle point. So the array is getting passed and this part is getting passed in the merge sort, and then the right part is getting passed into the merge sort. Again this will be called recursively, and this part will be getting divided into S and mid, and again S and mid. Okay, means mid and end. Again this part will be called and it will be divided into divided by 2. This will happen until this condition occurs when S is greater than E. Okay. So by these two parts we are merging the left and we are dividing the left and the right parts, and to merge it after means if the left and the right part are no more further divisible, we'll be just merging the left and the right part using this merge function. Merge function is what we just explained here. This is the merge function. Okay, so this will means set the elements in the increasing order. Okay, so that's all what we have to do in the merge sort. The next question is of two trees. Two trees are same when all the nodes present in the right and the left are same for two trees. Okay, so basically what we are doing, we are checking this is same or not, then we are checking this is same or this is same, right? So each time when it is same, at that time we will be returning true. If it's not same, we will be returning false. Firstly we are checking if p is null or q is null. At that time return if p equal to q. Okay, that's all we'll be returning. Else if it's not null, we will be checking its children. If p value and q value is same, means this is the two trees here, this is the tree number 1 and this is the tree number 2. We are checking if this is same or not. If this is same, we will be returning true. And p left is equal to q left or not. P left and q left, this is same or not. Again we are calling the same function here. Okay, this function is recursively called, and then we are checking right also it's same or not. If it's same, again we are since we are calling recursively, this children's left and right children is checked, and this children's left and right children is checked. Okay, if this is also same, we'll be returning true, else we'll be returning false. Okay, then when the means in the normal way, if we traverse, what answer we get is same as the, if in the reverse order if we traverse, that time we, the answer which we get is same. Okay, so what we have to do is first we have to calculate this traversal, and then we have to calculate what is the reversal traversal. Okay, so how do we do that is very simple. Suppose that there are three nodes here, 1 2 3. Okay, and another three nodes are here. In the reverse way, how we do, we just start from here and then reverse the pointers. Pointers and traverse from here, we'll get the reverse order, and this is the straight order. We will be checking each time if you are getting the same elements or not. If you are getting different elements, it's not palindrome, else else you can say it's a palindrome. Okay, but before that we have to check if the list is circular or not. So for that we'll be using the concept of slow and fast pointers, which I have discussed in the theory part as well. So that's what we are doing here. First we'll be checking if it's null or the head dot next is null. If it's null, it's true, because only one element is there or no element is there. Both are in the form of palindromes. So I will be taking two pointers. Slow will be pointing to head, and fast which will be pointing to head initially. Okay, while fast of next is not equal to null, and fast of next is not equal to null, slow is equal to slow of next. Okay, so if you don't understand what's this happening, refer to my theory explanation of slow and fast pointers. Okay, so if it's not a circular list. Okay, so if any of these reaches nulls, it means it's not a circular list, will come out of this while loop. Okay, and then what we are doing here, slow dot next is equal to reverse list slow of next. We are calling the reverse list function. Okay, what does reverse list function do? It will just change the pointer's position. Okay, next is equal to header of next. Header of next is equal to previous, so where head of next was pointing to, it will point to previous now, and previous is equal to head. Now previous will become head. So this is the way the linked list will be working. Okay, this for one node, it will be calculated for all the nodes. Okay, so that's what we are doing here. We are calculating a reverse list and storing here itself, and then we are again doing the slow and the fast pointers, and then we are starting from the reverse end, and then we are checking if any of the value are not equal. Okay, we are having two lists. One is the normal list, or there is the reverse list. Normal list is starting from the head pointer, and the reverse list is starting from the slow pointer. Now we are checking that if each of these elements are same or not. If this is same, it's okay. If this is same, okay. Like that we'll keep on checking all the elements. If any of the elements are not equal, it means it's a false pointer. Okay, that's what we are checking here. And if this case doesn't this situation does not happen, that it encounters this statement, that means all the elements are same and it returns as true. Okay, going to the next one, which is reverse level order traversal. Consider this tree here. Okay, so in this tree, let's write down some numbers here. So it is 1 2 3 4 5 6 7. Okay, what does reverse level order traversal mean? Firstly, what is level order traversal? Level order traversal means it will travel like this: 1, then 2 3, then 4 5 6 7. In reverse, what will happen?
4 5 6 7 will happen, then 2 3, then 1. Okay, so basically what we are trying to do is whenever we encounter this node here, we'll be using a queue and a stack, this queue and a stack. If I encounter a node here, at that time we'll be storing the node in the queue. Okay, this is the queue, this is the stack. We'll be storing one here, and we'll be checking if queue means there is no more nodes here in the queue, only one is there. Whatever is there, we'll be outputting it. Okay, so one will be stored here, and then we'll be checking if there is means children for one or not. First we'll be storing the right children, then we'll be storing the left children. So 3 and 2 will be stored here, and after that we'll be again doing the same thing. If 3 has children or not, we'll be first traversing 3 here, then 3 has children, yes, 7 and 6. So we'll be storing here 7 and 6, and then we'll be coming back. Then the second is 2 has children or not, yes, 2 has children, so that children will be stored here, which is 5 and 4. So after 6, 5 and 4 will be stored. 7 has children, no, it will be directly stored. 6 has children, no. 5 has children, no. 4 has children, no. Now if you reverse means print it in this way, what will be printed is 4 5 6 7 2 3 1. Isn't it the reverse auto traversal? Right, so this is the concept. If you did not understand, you can always replay and watch the explanation again. So let me take you to the code here. If it's if the root is not there, means if the root is null, at that time it will return as means it will just return there is no reverse order traversal for a null root. So we'll be taking two things here, stack and queue, and will be queue dot push root, like when we have pushed into the queue, right? So that's what we are doing, queue dot push root. And while queue is not empty, while it's not empty, you have to take the root as queue dot front and pop it. So we'll be popping it and putting it into the stack. Okay, so what we are doing here, if root dot right and left is exist, that right children will be placed first, like in the case 2 was placed, 3 was placed, then after that left children 2 will be placed. After these two things are placed, stack dot push root, what was root? 1. So in the stack 1 will be placed. Okay, so that's what we are doing here until the queue becomes empty. So until queue becomes empty, we have all the elements in the reverse order in the stack, and after it's not empty, we'll be outputting the root dot value. Okay.
Moving on to the next question, which is the next greater element. Okay, so what do you understand by the term next greater element? So suppose that there is an array here, and if I ask you what is the next greater element of each of these elements, so 2 1 7 4 3. Okay, so what is the next greater element of 2? It is 7. What is the next greater element of 1? It is 7. What is the next greater element of 7? It is means there is no next greater element. What is the next greater element of 4? There is no next greater element. What is the next greater element of 3? There is no next greater element. Okay, so suppose that this is a circular array, which means that if you want to find out what is the next greater element of 4, we could check here. If it's not there, again we can come back and check from here till 4. So in that case we'll get as 7. So both of these cases we have to handle. Okay, so if I copy this array here, like the same array if I make here 2 1 7 4 3, and then I need not again come back, but directly I can check after 4 what is the next greater element, I'll get as 7. Okay, so that's what's happening in the code here. We'll be given with a nums array here, as I had made one as an example. We'll be taking the length first, and after that we'll be creating another vector, which is nothing but an array having n elements, which is initialized as -1 initially. We'll be taking a stack also, and we'll be running a for loop from I is equal to means 2n minus 1 till I is greater than or equal to 0. We'll be checking from the left part here, which is the next greater element from here, then we'll be coming to here, which is the next greater element, and in doing of this we'll be using a stack as well. Okay. So what we will be doing is, while stack is not empty and s of top is less than nums of I percentage n is just for the double elements, right? Because we are using 2n minus 1, so that's why we are using percentage n. Okay, while this is not the case, at that time st dot pop. Okay, if I is less than n, then do the following. If it's not empty, at that time ng of I is equal to st dot top. So what we are basically doing is we are pushing here. See, if these two cases are not true, at that time what we'll do, we'll push it. So whenever we get an element, like for example, if this is the array here 1 4 7 2 6. Okay, if this is the array, if stack is empty, we will first push 6 here, and then right here is -1. Then again we'll come and see 2, and we'll see if there is any less element than 2. There is no less element, and what is the top of the stack, that is my answer. So I'll be writing here 6. Okay, and after that I'll be storing 2 here, and then I'll be checking for 7 if there is any lesser element than 7. If there is lesser element, we'll pop it. If there is another lesser element, we'll pop it, and after that we'll store as -1. And since there is no other element present in the stack will have the content as 7 only. After that we'll come to 4. We'll check if there is any less element than 4. There is no less element, so we'll store 7 as the next greater element, and after that we'll store 4 here, and after that for 1 we'll check which is the next greater element present here. It is 4, so we'll be storing 4 here, and we'll check if 1 has any element, means any element is here which is less than 1. There is no such element, so we will stop the array. So what we answer we got here, 4, 7, -1, 6, -1. So basically what we did, we checked here if there is any element greater than it. If it's not there, we'll put as -1, else we'll put as whatever element we get here, means the next greater element. And if there is any lesser element, we will pop it out, because we need the next greater element, and we'll store it here. Okay, whatever answer we get, we store it here, and that will be the next greater element for the leftmost elements. Okay, and if you want a circular array, if we will be putting the same thing here, like 1, 4, 7, 2, 6, and we'll be doing the same thing here. Again we will come back here and check this same things again. So when we have 6 here, means after I have done this one, means this thing will be stored here. After that 6 is present here. For 6 again I will be checking is there any element present in the stack. Yes, there is 4, so I'll cut the 4, and I'll see there is 7. 7 is not less than 6, so I'll store it as 7, and I'll add 6 here. So as you can see, the answer is present here, 7, right? 7 is the correct answer for 6. So next great element if you consider a circular array. So that's what's happening here. Here we are starting from the copying the array twice, and we are starting from here, and we are running till here. First iteration will set the arrays here, and after that when we reach here, we will be having the next great element in this part. So that's what we are doing here, and then I will be returning the result array. Okay, the next question is quick sort. Quick sort, basically what it will do, firstly if you have this array here, we'll be dividing this into 2 parts. We'll be selecting a pivot element. Pivot element means the left of these elements are all lesser than this element, and right of these elements are all greater than these elements. So our task is just to order these elements in the respective orders, right? Like ascending or descending. So again we will pass here and find out the pivot element left, right. Again we'll find a pivot element left, right, and here also. So what's happening is whenever we get a pivot element, that's the exact position of the means the element, right, in the array. So we have been given with we'll be using 2 functions here. One is partition and another one is quick sort. So it will call quick sort first. So L is equal to this one and H is equal to this one, and then if L is less than H, yes, L is less than H, pivot is equal to partition of L comma H. So we'll call partition, and it will partition it into 2 parts with the pivot element as returned value. After that we need to sort this and sort this. So if you understand what is partition, our task is over, right? So let's see what is partition. What does partition do? I've got an element here, we have got L here and H here. Okay, so pivot element is A of L. Initially it is the first element here. I is equal to L, J is equal to H. I will start from here, J will start from here. Okay, while I is less than J, what we will check, if A of I is less than pivot, I plus plus, means I starting from here. If I is less than or equal to pivot, then I plus plus. If A of J is greater than this one, so whatever element we have here, is it greater than pivot, then keep it here only and move J in the backward direction. So what we are basically doing is we are just selecting those elements which are like greater than a pivot and less than pivot here. So that is to be exchanged. Why? Because less than pivot element should not be here, it should be here, and more than pivot element should not be here, it should be here. After that a separation is done when L and H come to this middle point here. At that time we have all the elements greater than pivot in this part and less than pivot in this part. So we'll just take the pivot element and place it in the middle, and this element will come here. Okay, so that's what the pivot function does. The swapping, if it's violating the rule that the lesser element is present here and the greater element is present here, that time we'll swap. Okay, and finally when we get the position where all the elements to the right and all the elements to the left are greater and lesser respectively, at that time what we'll swap is the position here and the element which you got here, the pivot element and this one. Okay, so that will be swapped and kept here. So if you want more information regarding this explanation, I'll be putting a link in the description box. In that I've explained quick sort in more detail, so you can go to that. Okay, so this was for the just for the one partition. When we get the partition here, this is the exact position. Like that we will again do the pivot, we will call quick sort for this part as well as for this part. Like that will keep on happening recursively, and the array will be sorted. Okay, Moving on, we have the next question, target sum path in BST. Target sum path means what? If this is the tree given to us, okay, let's suppose there are some nodes here. We have to find out the target sum path. Target sum path means which path if I go through, I'll get the particular sums value. Means if this is 1, 2, 3, if I go through this path, I'll get a 6. If the target is 6, this is my target sum path. So for that, what I will do, firstly, I'll check if the root is null. At that time, I will return, or else I will call node.left target. Firstly, I'll go to the left part and I'll see if I'm getting the answer or not. How will I get answer? Suppose that if the target is 7 and the value which I got here is 1. Okay, so here I have to find out the 6, right? 6 is the answer which I have to find, which is the sum. So I'll be taking complement as target minus node dot data. So target is 7, node dot data is 1, so it is 6 here. If node dot data is less than means the complementary value, at that time what I will do, I'll find root comma comp, which root has the value 6. At that time I will find here in the left part of the array. If I get, I'll be printing it, else I will be moving on. Okay, so that's all what is in the target sum in BST. And this just to partition, like to find where it is. How we'll find? First we will be checking if it's greater than data. Greater means move to the right, lesser means move to the left, else that's the root node, right? That's the correct answer. So these are the two functions which you have to write under the topic target sum path in BST. Moving on to the next one, we have check redundant parentheses. I'll be giving an example here. If suppose that this is the example 1 plus 1 and into 2. Okay, this is the example which is given to us. Okay, so what we are trying to see is if there is redundant parenthesis or not. There is redundant parenthesis, right? If this is into here, at that time we can remove this one, still the answer will be same, right? So how will we identify is that? Because if you have opening braces and there comes a closing braces, that's a redundant one, right? Because that was not needed if it was in somewhere middle. So that how we'll be checking is, firstly we'll be taking a string here in which the order of parentheses and the operators will be stored. After that we'll be using a stack here. In stack, if we get the answers, we'll be using a for loop here, and we'll be traversing the string. Okay, this is a string here in which the order is given, like operators and parentheses. If it is a plus, minus, into, or divide, we'll be pushing it in the stack, like into, divide and all. And if it is a opening braces, will be pushing into the stack. If it's a closing braces and the top of the stack is opening braces, at that time only the answer will be false, else in the rest of the cases it will be true. Okay, and as usual, if it is like plus or minus, we'll be just popping it. Okay, so this is the code for the checking of redundant parentheses. Moving on, we have the BST addition. Addition means adding a new node to the existing tree. Okay, so how we'll do that is, firstly we'll check if it's null, and if it's null, we'll just run the new node. If it's having some value, we'll be checking if the value of the current is less than value. If it's less than value, we have to move to the right and we have to place there. Else if it is greater than the value, we have to move to the left and place it, and that's what we'll do in this code. And finally, when the item is placed, we'll be returning the root of the main tree. Okay. Next question is about Fibonacci series, very important one. Fibonacci series means what? 0, 1, 1, 2, 3, 5 and so on, like adding the previous two numbers. So for previous two numbers, I take A and B and we'll be adding A and B and storing in C, and in next iteration the A's value, C, A, B, C is there, right? B's value should come in A, and the sum which is stored in C, which is nothing but A plus B, that should come in B. So B will come in A and C is nothing but A plus B, that will come in B for the next iteration. Like that, if we do for the whole for loop, and how many times we have to do, n for n times for the nth Fibonacci number, and then in the C we will have the answer. So we'll be returning C. Okay, that I forgot to write to return C, but that's the final code. Okay. Moving on to the next question, pre-order iterative traversal. What does pre-order mean? Pre-order means NLR. NLR means node, print the node, move to the left, then to the right. For example, if there is a tree here like this, at that time, what is the pre-order traversal? Print this node, move to the left, print this node, move to the left, print this node, move to the left, there is nothing, move to the right, there is nothing, come back here, move to the right, print it, again move to the back, and move to the right, and print it, and move to the left, there is nothing, move to the right, there is nothing. So this is the order in which the nodes are getting printed, that is known as the pre-order traversal. So what is the order? NLR, right? So that's what we are doing here. We are checking if the root is null. If it's null, we will be returning the same array here. else we'll be using a stack here, and stack dot push root. In stack, what we will do, whenever you encounter a new node, at that time that node has to be checked if there is a right children or left children or not, so that node will be stored in the stack. Okay, so when this traversal is over, we'll be popping it. Before popping, we'll check if this it has the previous node in the left child as well as the right child. Firstly, left will be stored, then right will be stored. Okay, that's what's happening here. While stack is not empty, means whenever if the stack becomes empty, that means the traversal is over. Okay, firstly we'll be pushing the root node. After that, we'll be popping the root node, and we'll be checking if the will be means pre-order is the array in which we have to return. So in that array, the roots value will be stored. After the value is stored, we have to check if right is not null. If right is not null, store right. If left is not null, store left. Then again, the right was stored, so right will be accessed first. Okay, so in that the same thing will happen. Right will be accessed, then left and right, and so on. Okay, so when the stack becomes empty, that means the traversal has been over, and we'll be returning the pre-order traversal array. Okay, moving on to the next question. The next question is to find two numbers in a given array whose sum will be equal to the key number. So here's the array given to us, and what we'll do, we'll use a map here. So we'll be writing which all numbers occurs in the array, and after that, to find out the sum, what we'll do, we'll subtract this number. For example, if the sum is 8, okay, and I have got a number 6 here, then 5, 1 and 2. At that time, what I will do, I'll store 6 here, 6 is stored, 5 is stored, 1 is stored, 2 is stored. When I encounter 6 for the next time, what I will do, I have to search for 2. What I will do, 8 minus 6. 8 minus 6 is 2. I'll check if 2 is present in the keys or not. If it's present, means 6 and 2 form a pair, and they are the two numbers in a given array whose sum is equal to the key number. Firstly, we will initialize all the numbers here with 1. After that, we'll check if sum minus array of I is greater than 0, that means it's present in the map or not. If it's present, yes, else it will show as not present. Okay, moving on to the last question, traveling salesman's problem. This question I have explained in greater detail in the I'll put the link in the description box. You can go to that. So what is the basic idea behind traveling salesman problem? Traveling salesman problem means if there are nodes here, and each node to travel from one node to other node, there is a cost associated with that. Okay, so traveling from here to here is like 10, and coming back is 20. From here to here it is 30, and going is 40, and so on. Okay, so what is the best way to start from this node and visit all the nodes with the least cost? That is the traveling salesman problem. Basically, we'll be trying all the possible combinations. What I mean is, what are the possible combinations? Go like this, then like this, then like this, or go like this, then like this, then like this, or go like this, like this, like this, like that. Many combinations will be there. Each time we'll be traversing in a single way, and then we'll be storing that sum in a particular element. Okay, means how much it was costed, and then we'll be traversing in a different way and checking how much it will cost. Okay, so it will be done in a recursive way. First we'll check for this one, then this one, then this one. When we go for this one, we have a few more options like this or like this. When we go for this one, we have few more options like this or like this, right? So all this combination will be checked in the following way. We have means it will call recursively, the same function will be called recursively. Okay, so the function name is tspdp. So here the CRA is passed. This is how much means all the nodes are present from one node to other node, how much is the cost, and tour is the initial tour, start is the starting point, n is the number of nodes. We'll be initializing these things here, and if start is n minus 2, we'll be returning the total sum. Means n minus 2 means what? Only two options are there, that answers sum will be returning. Okay, else what we'll do, we'll be first having minimum cost as infinity. We'll be starting from I is equal to start plus 1, and we'll be doing the following operation. So what it basically does is, we'll calculate from this node to this node how much it was costing, and after that, here if 3 nodes are there, how much it will cost, which is the minimum value among that. Okay, so we'll be checking by calling this same function again, tspdp, and passing the values here. If it's less than the minimum cost, if it's less than the minimum cost, we'll select this one. Else if it is more lesser, we'll select this one and discard this one, and whichever is minimum, we'll select that, and that will be stored for this one. And this one also will have it will be among the 3, right? So here what cost it came, here what cost it came, here what cost it came, that will be means compared, and that the least path will be selected. Okay, so that's what the basic outlook of the traveling salesman problem is, and finally we'll be returning the minimum cost. Okay, so that's the questions in the internship pack, and make sure you practice these questions very well before going to any interview. And thank you so much for watching. I'll see you in the next one.